Do subscribe to Ekeeda channel and press bell icon to get updates about
Chapter some basic principles and techniques in organic chemistry, and we are doing the topic rules for the organic compounds having the functional group. Hello friends, now we are going to discuss about the rules for the IUPAC nomenclature for the organic compounds having the functional group. So in the previous lecture we have studied about the rules of the IUPAC nomenclature for the organic compounds just like for alkane. But now we are going to study about the IUPAC nomenclature for the one having a functional group. So what are the different criteria that we have to keep in concern, and then only we could able to give a particular nomenclature according to the IUPAC. So let us understand that. So there are certain rules on which we could follow and for which we could be able to write the nomenclature of a particular organic compound which consists of a functional group. So talking about the first rule, and there are various rules, but I have just randomly arranged it in a manner so that we could study point wise. And talking about the first one, that is the functional groups in the molecule is the first identified and accordingly appropriate suffix is being used. So this indicates that suppose if an organic compound consists of, suppose if we could say that an organic compound which consists of a functional group, and suppose that functional group is only the one functional group that is been attached to the organic compound. For example, let me give you, that is, so this CH3 is basically known as ethane. So this is the one which don't have that functional group that we are concerned with. Suppose what if we have, that is CH3, CH2, Cl. So now this is CH3, CH2, Cl, where Cl is basically the functional group. So now this whole organic compound is basically known because of the Cl, or a halogen atom that has been attached to a hydrocarbon. So therefore the identification of this would be an alkyl halide. So therefore this functional group plays a very vital role in making or in classifying the organic compounds. So that is what we have got to know in the first point, that is the functional group is in the molecule is first identified and accordingly appropriate suffix is being used. So therefore in this case we could say that this would be known as ethyl chloride, or we could call it as chloroethane. So now therefore the word chloro, suppose if I would write over here as, so in this case, the chloro is the one which is in the prefix, while the ethane is the one which is in the suffix. So that is the reason that according to that we have used the suffix, and we have considered that how many number of carbon atoms are over there, and this is what we have taken an example. So now talking about the next one, that is the second rule is that the longest continuous chain of the carbon atoms having the functional group is being selected. So suppose if we have a hydrocarbon and in which any of the functional group is been attached, and so we have to choose that chain which consists of the functional group. For example, suppose this is an example that we have, and for which we have to select the longest chain, and as you know that it is the rule of the IUPAC nomenclature that we have to select the longest chain which consists of carbon atoms. So if I select the one which has the more number of carbon atoms, like this one, that is 1, 2, 3, 4 and 5. So obviously this longest chain consists of 5 carbon atoms. But talking about the functional group, because it consists of a functional group, and that functional group is basically COOH. So we have to select the functional group in such a manner that it should be included in the longest chain that we are selecting. So that is the reason that we will select the longest chain not as this one, as we could prefer in terms of an alkane, that is 1, 2, 3, 4 and 5. But since the functional group is present, so therefore we'll select the longest chain in such a manner that it should also consist of the functional group. So therefore this one would be the longest chain which have included the functional group. And now let us understand that what is the next point that it is been mentioned over here, and that is basically the longest carbon chain is numbered from that end which is nearest to the functional group. So taking the previous example as it is, so suppose if this was an example that we have to go over for the last point, and in this case we have got to know that we have to number in such a manner that it should start with that end where we could receive less number or less number to the functional group. Suppose in this case the functional group is basically the COOH group, or we could call it as carboxylic acid group, and so therefore the numbering will start from that end where we could find the functional group nearer to the longest chain. And in this case we can't start the number from this carbon, because if this is the first carbon, this one would be the second, third, fourth, and then this would be the fifth carbon atom. So that's the reason this number should not be end from this end, while the number should start from this end. So therefore this is the functional group that we have got to know, and that's the reason that we'll name it as, because it is specifically it is of carboxylic acid. So suppose if any group it would have been there like that of an halide, so therefore this one would be the first carbon. So therefore this is I could call it as a first carbon over here, 1 2 3 4 and 5. So this is what the third rule says, that is the longest carbon chain is numbered from that end which is nearer to the functional group. So that is what we have did. And now talking about the next point, that is using the appropriate number of the functional group, the complete name is being written. So therefore, so the appropriate number has been mentioned over here in this case, and by using this thing we could be able to write the complete name of this organic compound. So talking about this thing, and since the substituents are also been attached on the second carbon atom, as you could see, and there are both the substituents groups are basically the CH3 groups. So therefore the name of this would be 2,2 dimethyl, and the one which consists of the total number of carbon in this is basically the five carbons are being attached in a straight chain, and it including a COH group or a functional group. So therefore the name of this would be pentoic acid. So therefore we could call it as 2,2, that is pentanoic acid. So that is the name of this, is what we could give. And so this is an example. So let us talk about the next one that we have, that is this one. So talking about the fifth point, and the fifth point says that the functional group that is F, that is fluoro, chloro, bromo, iodo, NO2, OR, R, this is alkyl, AR aromatic, that is it could be a benzene also, are always been written in the prefix substituent. So therefore that's the reason that suppose if we have took an example like this one, if I would say, suppose this is an organic compound, and for which suppose if we have followed the first rules, first few rules that we have mentioned over in this lecture. So in this case we have got to know that this is the one which has a functional group not of any kind of methyl group, but yes of the bromine. So here we have identified the functional group, and the next thing that we have to do is, yes, we have to select the longest chain which consists of this functional group. So since it is a straight line, so there is no reason to find an alternate option. So therefore this one would be basically the straight chain. And talking about the next thing, that we have to select the longest chain and we have to number it. So the numbering will start from this carbon, because this is the functional group that doesn't consist of any carbon atom over here. So that's the reason that this one will be the first carbon, and starting with this we will end it till the last. So therefore this is the first, second and third carbon atom, and according to that we could give the name of it. So in this case the functional group is bromine or bromine atom. So therefore the name of this would be, because the bromo is attached to the first carbon atom, so therefore the name of this would be 1-bromo. Either we could write it in this way, that is 1-bromo, and the total number of carbon in this case or in this organic compound is basically 3, and in the straight chain also. So therefore we could call it as propane. So therefore the name of this is 1-bromo propane. So if you notice that the functional group that is bromine, it has been attached, and we have studied the that is the fifth point over here, and which says that the functional group like fluoro, chloro, bromo, iodo, NO2, OR, so this should always be preferred in the prefix substituent, as a prefix substituent. So that's the reason that bromo should be always in the prefix. So that is what we have seen over here, that is it could be named it as 1-bromo propane. So this was an example that I have discussed, and let us move on to the next point. And the next point is, suppose in case of polyfunctional compounds, one of the functional group is chosen as the principal functional group, and the compound is named on that basis. So this is what I wanted to explain. Suppose if polyfunctional groups are being present, means more than 2 functional groups are being present in the same organic compound. So which one should be selected, and based on that we will give a particular name to the organic compound. So for example, so this is what we are going to discuss about also, but just for an example, suppose if I say, that is, suppose in this case, that is I'll take another example, that is CH3 CHCl. Here it is also suppose H, and here it is CH2, suppose like Br. So therefore here it is a poly functional group has are been present over here, that is bromine and chloro, or bromo or chloro. These two groups have been present. So that is the reason we should consider that name which should come at the last, or we should prefer the name in such a way that we could be able to write the name of the organic compound. So that is what this point is mentioning about. That is the point number 6. And now let us move on to the next point, because in the next point let's see what it from which we could get to know. And the next is, that is, the remaining functional groups are named as the substituent using the appropriate prefix. So for example, that the same example I would consider over here, that is this one. This is the example where we have mentioned it over here, and there are two functional groups, that is the chloro group and the bromo group. So we have to select the longest chain first, and we have to identify which are the functional group over here. So therefore bromo and chloro, these two are the functional groups that we are observing over here. So we have to select the longest chain that should be included with that of the functional group. So therefore this is the longest chain that we have. And the next thing that we have to do is we have to number it. So we have to number it in such a way that the substituent or the functional group should get the less number. So therefore, if we number it from here, that this would be carbon number 1, this would be carbon number 2, and this one would be carbon number 3. But talking about this one, the bromo is attached on the carbon atom here, and that's the reason that the numbering should be given from this end only. So that's the reason we could name the number as 1, 2, and 3. So this is the number that we have given over here. And yes, now the most challenging thing is we have to select that which one should be in the prefix one. So if we compare to that of an alphabetical order also, so in this case we have got to know that the bromine is the one which will come first, and after that of chlorine. So we could write the name in this manner also, that is 2 chloro, 1 bromo, or we could write it in this way, that is 1 bromo, 2 chloro, and the total number of carbon in this straight chain is basically 3, making this to be called as propane. So this is what we have made, and that's the reason that we have gone through the point number 6 and point number 7, and this is what we have got to know. So that is the thing, and we have made the rest of the functional group as an prefix. So that is what we have mentioned over here, and let us start with the another one, that is point number 8. So in this case, what we are studying is the following priorities are being chosen as the principal functional group for the base name. And so in the previous one that we have studied, both the functional groups, they were belonging to the halogen, but they can be different also. So that is what we are concerning in the 8th point. And suppose the functional group consists of among this, any two functional groups are being considered, or any two functional groups are being attached to the organic compound. So what would be the preference? So talking about the first one, that is the carboxylic acid group, that is COOH, this should be preferred first, and then it will be followed to an ester group, and then it will be followed by that is an amide group, and then we should follow that is cyanide or cyano group, then aldehyde, and then keto, then hydroxyl. It could be of phenol also, or it could be of an alcohol also. So after OH, and this OH could be alcoholic, and or we could call it as phenolic, and then it will be for NH2, that is for amino group, and then it is for that is alkene, and then it will be for an alkyne. So these are the priorities that we have mentioned over here, and this priority is the thing that we should follow, and that would be very much helpful to give a nomenclature for a particular organic compound or for a particular organic structure that we have. And this was the 8th point. And regarding that, let us understand the next point also, and which says that if two functional groups of the same type are being present, then they are indicated by using di, tri, etc. before the class name suffix. So that is the thing that we have did earlier also. And suppose I will give an example of this one, that is there are few questions that we are going to do a nomenclature on that also, but let me make you understand the 9th point. So in this case, basically suppose if we have like this one, that is CH2, and here it is ClC. So this is an organic compound that we have, and in this case we have to do, that is we have to identify the functional group over here, and that is Cl. But the next thing is we have to number it also. Yes, we have to number the carbon chain in such a manner that the lowest number should be received to that of the functional group. So therefore there is no chance to we get confusion over here, so therefore we could write or we could number the any carbon from this end or that end, because they are symmetrical also, as well as from both the end they will receive the same smallest number. So therefore I will name it this as carbon number 1 and this as carbon number 2. So in this case, the functional group that are been attached to this organic structure is having the same functional group, that is the chloro group. So therefore we could write it in this way, where the position of the chloro group should also be mentioned over here. So therefore the position is on the first carbon as well as on the second carbon, so making this to be called as 1, 2, because 2 times the same functional group is been attached. So therefore I could write it as 1, 2 dichloro, and the one which consists of the longest chain is basically the 2 carbon atoms that are in the longest chain. So therefore I could name it as ethane. So therefore this is the name of the above example that I have mentioned over here, and we have followed the ninth rule also. So based on this thing only, we should the main thing that we will observe is that during the name, the prefix one is the one which will have the functional group and that are been attached mostly, while that of the suffix will consist of the main that is the main name of the organic compound. So there are few examples that we are going to look out, and let us see that how can we give the name to those organic compounds. So starting with the first one, that is so this is the one that we have, and we have to give a nomenclature, and that also to be based on IUPAC nomenclature. So this is the one that we have, and what is we have to do is we have to follow the IUPAC rule, in which the first is we have to select or we have to choose which one of is basically the functional group. So in this case, that is this OH group or this hydroxide group is the functional group. So that is what we have selected over here. And the next thing that we have to do is we have to select the longest chain that consists of the functional group, and that longest chain should consist of carbon atoms. So therefore we could say that if we have chosen this to be the longest chain, that is 1, 2, 3, 4, then this would be the longest chain, including the OH group or the functional group is already or is directly being attached to this longest chain. So therefore we could write it over in this way also, as you could see. Suppose if this is the longest chain, then this OH is been directly attached to as a branch also, but it has been attached to this longest chain. So therefore this one would be the longest chain that consists of the functional group, that is OH. So now this has been done. So the next thing that we have to do is we have to do the numbering. So therefore the numbering will start from that end where we could get the functional group that is very close to that end while numbering. So therefore if we number it from here, so therefore this one will be the first carbon, second, third and fourth. But what if we number from this end, that is if this is carbon number 1, this is carbon number 2, this is carbon number 3, and the functional group OH would be attached on carbon number 3. So therefore that won't be an appropriate one so as to follow the IUPAC rule. So that's the reason that we'll follow from this end. So therefore this one will be the first carbon atom, this one will be the second, this is third, and this is fourth. So now this OH group is the one which is being acting as a functional group, and meanwhile the substituent that we could see, and that substituent is basically attached on the second carbon atom. So therefore we could call it as that is and overall the identification of this organic compound is based on alcohol, because this whole thing is an alkyl group that has been attached to OH. So therefore if an OH is been attached to an alkyl group, then the overall organic compound is called to be an alcohol. So therefore in this case the substituent is being acted by CH3. So therefore we could name the CH3 as that is 2-methyl, and the total number of carbon that has been present in the straight chain is 4. But talking about the functional group, the functional group is attached on the carbon number 2. So therefore the name of this would be, because it consists of 4 carbon atoms, then the name of this would be butane. But this is not butane, this is a butane as well as an alcohol. So therefore the name of this would be 2-methyl butane 2. This 2 is for the position of the functional group that has been attached, and that functional group is basically the OH group. So therefore this 2 represents the position of the OH group that has been attached on the straight chain, and that is the reason that the name of this is butane 2-ol. So this is the IUPAC name of the first one that we have did, that is 2-methyl butane 2-ol. This is the functional group where we have mentioned over here. So now moving to the next one, that is the second one which we will follow the IUPAC rule and we'll name it. So this is the structure that we have, and for which we have to give the IUPAC nomenclature. So the thing that we have to do is we have to identify, because it consists of functional groups, so therefore we have to identify which are the functional groups that are being attached in this case. So the first functional group that I could see is basically a ketonic group, and the next is basically the carboxylic group. So this are been selected, and this is the longest chain that we could get, but that is not a challenging thing. The most challenging thing is we have to prefer which of the functional group. Yes, that is the main point. And after that we could give the numbering, and then we'll give the name for this one. So talking about the carboxylic acid, and if we have got to know that is when the functional group are being present and the both are in different functional group, then the carboxylic acid is the one that we could see here is as the ketonic group, and while that of the carboxylic group is the one which is at the first. So therefore we should give the priority as a principal functional group to the that is carboxylic acid that has been present over here. So therefore there is a competition between this carboxylic acid as well as this keto group. So that's the reason the priority has went to the carboxylic acid, and that would be the principal functional group. So therefore this would be the one that will start from here. We will start the numbering, and that's the reason that the numbering will start from here as carbon number 1, carbon number 2, 3, 4 and 5. So now this is the numbering that we have did, and the next thing that we have to do is, yes, we have to basically name it. So how can we name it? Because it consists of basically 5 carbon atoms, and it is mainly because of the principal functional group, that is because of the COOH or a carboxylic group that is been attached. So therefore the name of this would be pentanoic acid. But if we could see that on the 4th position the functional group has been attached, and that would be written in the prefix. So therefore in this case we could see that C double bond O is also known as oxo. The functional group is also known as oxo. So therefore we could write it as, that is 4-oxo, that is methane, ethane, propane, butane, pentane, and the name of this would be 4-oxo pentanoic acid. So this is the name that we have given to this this organic compound, and we have also followed the rule of when the 2 functional group are being present and the 2 functional group are being different, so we should prefer which of the one, that is the priority one. And now let us move on to the next one that we have, and the next one is, so this one is the next one that we have, and we have to give the IUPAC nomenclature to this one. And the first rule that we know commonly is we have to select the longest chain that consists of the carbon atom. So that is the thing that we will choose the longest chain that consists of carbon atom along with that of the functional group. So here we have to identify which are the functional group that are been attached over here. So therefore the functional group that has been attached over here is basically a halogen group, that is a chloro group, and that of the another one, that is an alkene. So talking about this one, then we have to give the numbering. So let us understand that we have to select the longest chain that consists of carbon atom. So it is very easy to understand that the longest chain is basically this one only. And next the rule is we have to number it in such a way that the functional group should get the less number. So suppose if we number it from here, so therefore this one would be the carbon number 1, 2, 3, 4. I would write over here as 4, 5, 6. So this is the sequence that we get, that is 4, 6. So what if we number it from this carbon atom? So therefore this one will be the first carbon atom where one functional group is attached. So therefore this is the 1, 2, 3, 4, 5, 6. So in this case basically we have 2 options. So what if we suppose if we have numbered that is from this end? So therefore this one will be the first carbon atom, and where we could find a functional group. Second, yes, again we have found a functional group. Third, fourth, fifth and sixth. So this is what we have given the number over here. So we have 2 options right here, that is one is 4, 6 and the one is 1, 2. So we have to select which one of the preferred one, and that is basically we know it already, and that is 1, 2. So that is the reason that the 1, 2 is the one which has a less numbering to given to the functional group, and that's the reason we'll prefer that end, and that's the reason that we would number it over here as 1, 2, 3, 4, 5, 6. So this is what we have selected the number based on what we have did where we have identified the functional group over here. But talking about the substituents, in this case the C2H5 is acting like a substituent that is been attached on the 3rd carbon atom, while we have given the numbering also. And talking about the next thing, that we have to name it, but there are 2 functional group that are been that we could observe. One is carbon-carbon double bond, that is an alkene, and one is a halogen group, that is an chloro group. So therefore, suppose if we have mentioned over here, that is if we see that is the numbering should be done from which end. So the competition is between that is chloro and that of the carbon-carbon double bond. So as to name it, the numbering is been done, but while naming it, it would be preferred that the substituent should be named first. So therefore, at the third carbon atom, we could see ethyl group that has been attached. So therefore, we could write it as 3-ethyl. Then in this case, basically we could write it as the position of the carbon atom, the position of the chloro atom that has been attached over here, and that is Cl. So therefore, it has been attached on the first carbon atom. So therefore, we could write it as 3-ethyl, 1-chloro, and the total number of carbon that has been present in this case is 6. But we could find that this is not an alkane, this is an alkene. So therefore, the name of this would be 3-ethyl, 1-chloro, hex. But the second number, the second carbon consists of a carbon double bond. So therefore, 1-chloro, hex, 2-ene. So this is the name of the above one that we have represented over here, and let us move on to the next one. So this is the one that we have, and it consists of basically the functional group, and those functional groups are basically an aldehyde group, there are 2 aldehyde group, and 1 OH group that has been attached over here. So we have to set the number in such a way that where we could get the number to the functional group very less. So suppose if we have given the numbering from this end, so therefore this is the first carbon atom that we could get, and in the first carbon atom we get a functional group. Talking about this one, this is the second, third, fourth. Again we are getting a functional group attached on the fourth carbon atom, and fifth, and then again on the sixth. So therefore the sequence that we have got is 1, 4, 6. And talking about what if we have numbered it from this end, so therefore this one would be the first carbon atom, this one would be the second, this is third, fourth, fifth, and this one would be the sixth. So therefore this is the first carbon atom that we could get over here. So therefore this is the first one, second, this is third, then fourth, fifth, and sixth. So compared to 1, 4, 6 and 1, 3, 6, the one which is appropriate to give the number is basically 1, 3, 6. So that's the reason we will number it from this, and that is 1, 2, 3, 4, 5, and 6. So here basically two kind of functional groups have been present, two kinds of, and that is basically one is aldehyde group and one is alcoholic group that you could see over here, and for which we have given a sequence also, that is this one should be the preferred one while giving the principal functional group, while after that the OH group is been present, and that should be given we should give the priority after that. So therefore the OH group is attached on the third carbon atom, and that's the reason that it would be written as a prefix, while the suffix one will be having the one which has the principal name, and that is because of the aldehyde, as you could see. So therefore the name of this one would be, this OH can be written as hydroxy, so therefore I could write it as 3-hydroxy, and the total number of carbon in this case is 6, but I could find that there is an aldehyde group is present, and aldehyde is the one that ends with Al, and that's the reason that the total number of carbon here is 6, so making this to be called as hexanal. But it doesn't consist of only one aldehyde group, it consists of 2 aldehyde group, and that's the reason the name of this would be 3-hydroxy hexane, that is 1, 6 di. So this is the name of the structure that we have. So this is what we have explained about the IUPAC nomenclature of the one which consists of the functional group, and that's it. I have given a few examples over here, and I hope that you will try out more and more nomenclature for different kind of organic compounds containing different functional groups. So thank you friends for watching this video. I hope you have understood this video very clearly and will share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you.